Hello everybody, this is lesson 6 of the lecture Macroeconomics. I will discuss slide 60 to 66 of chapter 2, the long-run development of economies. The steady state of an economy, as derived in the preceding section, is a situation where GDP neither grows nor shrinks over time. In this version of the Solo-Sphären model, such a situation is possible because the problem of exhaustible resources is neglected. The implicit assumption was all production factors are either renewable resources, which means they reproduce themselves in every period, or they are accumulating. This means they are used up in every period to a certain amount, but this amount can be replaced by investment. This version of the Solo-Sphären model takes not care of the problem of exhaustible resources. Exhaustible resources are production factors that do not reproduce themselves and or whose erosion cannot be replaced by investment goods. For example, fossil fuels, metals or minerals. It is clear that in the presence of exhaustible resources which are necessary for GDP production, the achievement of a durable steady state can become much more difficult. You can use the diagram of exercise 18 from the questions for review of this chapter to analyze what happens if one of the production factors is exhaustible and its supply starts to shrink. It should be clear that in this case just the opposite of the case happens where the supply of a production factor is increased. Since we have analyzed the latter case on slides 43 to 48 in section 2.1 of this chapter, you simply have to invert the result of this analysis. To discover what kind of production factors are exhaustible, it is useful to reclassify the production factors we have used so far with respect to the question whether they are exhaustible resources or renewable resources. We have listed the production factors so far as arguments of the production function of GDP. As such, they appear here. Exhaustible resources are typically found among natural resources, which we have summarized so far under the shortcut capital letter B. Examples for what we call ideal type exhaustible resources are fossil fuels, metals and minerals. The supply of all these ideal type exhaustible resources on Earth is limited, since the Earth is a limited place. However, it is not so clear which of these exhaustible resources can be mined on extraterrestrial sources, especially asteroids in the so-called Kuiper belt around our solar system. A couple of years ago, private companies like Planetoid Mines Corporation, Deep Space Industries, Planetary Resources, TransAstra or the British Asteroid Mining Corporation have been founded, financed by private investors. They are currently mapping Kuiper belt asteroids with respect to exhaustible resources that can be found there. Resources like water, iron, nickel, cobalt, magnesium, aluminium, ammonia, platinum, and even gold have already been discovered there. Among the natural resources we currently use are, however, also renewable resources. Examples for ideal type renewable resources are solar energy, wind energy, and geothermal energy. Solar and wind energy are generated by hydrogen fusion processes on the sun, while geothermal energy is generated by nuclear decay processes in the Earth's mantle. It will take approximately another 5 billion years until all solar hydrogen is burned to helium. The sun will not burn out faster if we use this energy as a production factor. Consequently, from the current perspective, a nearly endless supply of solar energy is available. There is, however, another group of renewable resources whose ability to renew themselves depend on the degree by which they are used. I've called them conditional renewable resources. Examples for this type of renewable resources are forests, aquatic ecosystems, or the atmosphere. For example, a forest grows every year an additional amount of wood. If we harvest more wood in a year as is growing there, the forest will not be able to renew but shrink. It will get smaller and smaller until it finally disappears. If, however, the critical threshold defined by the quantity of wood that grows in a year is respected, the forest will be able to renew itself. It will neither shrink nor grow. It will be in a kind of steady state. The same holds for aquatic ecosystems, or let's say the uptake capacity of the atmosphere for industrial pollution. Aquatic ecosystems can typically absorb a certain amount of wastewater without being destroyed. But if a certain threshold of wastewater quantity is transgressed, the plants and animals which form the ecosystem will die, and the system will lose its ability to renew itself. After World War II, until the 70s of the last century, this was certainly the case for most German rivers and lakes. In those times, the River Rhine and the Lake of Constance, for example, had been biologically nearly dead. But in the course of the 70s and 80s of the last century, new bodies of law like the so-called Wasserhaushaltsgesetz or the Abwasserverordnung had been implemented, which defined maximum pollution concentration levels in the wastewaters. As a result, aquatic ecosystems like the River Rhine or the Lake of Constance have recovered and regained their ability to renew themselves. Current ecological researches show, however, that the pollution of aquatic ecosystems with microplastic is significantly higher than the ability of these ecosystems to neutralize microplastic. A debate how laws have to be adjusted to meet this problem has already started. A similar problem has emerged with the capacity of the atmosphere to renew itself. While most industrialized countries in the course of the 70s have established laws like the Bundesemissionsschutzgesetz, which regulate the emissions of sulfur dioxide, for example, a legal regulation to reduce the emissions of carbon dioxide below the level which can be absorbed by natural ecosystems has not yet been established. If conditional renewable resources are overused, they lose their ability to renew themselves and become exhaustible resources. In this case, they appear also in the category of exhaustible resources. As we have worked out, physical capital, technological knowledge, or public goods are typically accumulating production factors. As such, they are produced with the help of other production factors. They are therefore renewable or exhaustible if they are produced with renewable or exhaustible production factors. To understand the potential of solar energy, it is useful to compare the amount of solar energy which arrives at the Earth with the amount of energy consumed by human economic activities. Currently, the Sun sends 3.8 million exajoule per year in terms of solar energy to the Earth. 1 exajoule equals 31.6 million kilowatt. The yearly human consumption of energy equals 497 exajoule per year. It is the total consumption of all human activities estimated on the basis of world GDP per year. This means that the solar energy which arrives at the Earth in 1 hour and 8 minutes equals 100% of yearly human energy consumption. The International Panel on Climate Change has estimated that by the year 2100, total world consumption of energy will have grown to an amount between 750 and 900 exajoule per year. Consequently, even in a long-run perspective, the Sun provides affluent supply of solar energy. The only problem is currently that we have to improve the efficiency with which we transform solar energy in economically usable energy forms. The technologies used so far to do this are wind power, solar fuels, photovoltaics, and bioenergy. To sum up, there are basically 3 types of production factors. Renewable resources, with which a long-run steady state is possible if they are not overused. Exhaustible resources, with which a long-run steady state is possible if they can be substituted by renewable resources or extraterrestrial resources. And third, accumulating production factors with which a long-run steady state is possible if they are produced with renewable or substitutable exhaustible resources. Since we do not know in advance for certain whether it will be possible to substitute exhaustible resources in the future, a policy debate how to deal with this problem has started. In the following section, I will give an overview about several doctrines which have been proposed in this debate. So much for this lesson.